Welcome. My name is Jeremy Gernand, and I'm going to take a few minutes here to introduce myself and my research to you. So I'm originally from Texas. I went to college and earned a degree in mechanical engineering at Texas A&M University. And after that, I joined the Peace Corps and spent 2 years teaching math and physics in a small town in Guinea in West Africa. Following that time, I got my first engineering job as a safety and reliability engineer at NASA's Johnson Space Center in Houston. In total, I spent about 8 years in industry before I went back to school full-time and earned my PhD in engineering and public policy at Carnegie Mellon University in Pittsburgh. I now work in a field called environmental health and safety engineering. So what is that? Environmental health and safety engineering is a specialty focused on the dangers that people may be exposed to at home, at work, or in the outside environment, whether those dangers are caused by technology or dangers for which we try to use technology to prevent, or sometimes both. In that we try to analyze how severe a danger might be, how likely it may be, or how many people might be affected, and also what we can do about it. And doing something about it can either be designing better technology or making rules about how we design or how we use technology. Specifically, in my research here at Penn State, I mainly focus on two primary areas. One is measuring air pollutants in indoor and outdoor environments and trying to understand the risks of exposure better. And secondly, modeling or predicting what people's exposure to pollutants might be under a variety of different scenarios so that we can identify where we need to do more. I'm going to show you a few examples of what some recent undergraduate and graduate students have done while working with my group. Some undergraduate students a few years ago measured and analyzed the inhalation exposure of people using aerosol mineral sunscreens, and found that there were a variety of small particles known as nanoparticles inside these sunscreens. Now, thankfully, none of the concentrations of those particles were close to being high enough to warrant much concern about the risks of users, even if someone were to have a full-time job applying sunscreen. Another of my graduate students modeled or predicted exposure to particulate matter around natural gas wells, and found that the current rules about how close a natural gas well could be located to homes in Pennsylvania was perfectly adequate back when sites only had one or a very small number of wells. But she found that the rules were not enough when well sites had 6 or more wells. When that occurred, people who were living close to those sites could have been exposed to more particulate matter than is allowable under EPA standards. In 2015, 7% of well sites had 6 or more wells, and that number's only increased since then. Another student looked at the mixture of dust at a construction site that was going on Penn State's University Park campus to find out what the mixture of particles looked like and what they were made of. So you can see there was a variety of different shapes of particles that she found, and also there were a variety of different chemical components inside those particles. Thankfully, nothing in that mixture was found to be especially hazardous, and when we compared all the different exposures to the allowable concentrations defined by OSHA, everything was below the allowable limit. But there still need to be more research done on mixtures of exposures and how those really affect people's health. Just last semester, an undergraduate student was working with me with some new air pollutant modeling software. And we looked at setback distances around natural gas compressor stations. So these are the stations that gather up the gas from the different wells and then compress it to a higher pressure before they send it down pipelines to the cities where people live. So the safe distances depended a lot on the terrain, the hills and so forth around these compressor stations and the weather that we predicted. and a few were located close enough to cause violations of air quality standards a few times per year. And then finally, in the project that's probably most closely related to what EnvironMentors students may do while working with my group, we're working on a project right now to look at indoor air quality inside homes in Dakar, Senegal. So this project relies on a pair of two different commercial pollutant monitors to look at particulate matter, formaldehyde, volatile organic compounds, and carbon dioxide in real time. So this project is known as the RESPIRE project, and it's a French acronym, and you can see that laid out there. RESPIRE means to breathe. And if any of you have a desire to converse in bad French about air quality with an engineer, then I am definitely your person. But in this project, we face homes that have a very complex pollutant environment. People there in their homes are exposed to pollution generated in the home from cooking, from traffic, from dust storms, from waste burning, and salt spray from the ocean. So understanding how and when each of those sources contribute the most to people's exposure risk is critical to figuring out what we should do about it. And so that's our goal here with this project. So related to that, we have a set of tools and a set of environments that I work with in my lab. When we put those capabilities together, our monitoring, commercial monitors, our purpose-built or custom-built sensors, and our modeling software, when we put that together with the environments in which people may be exposed, or which we can create model exposures in test chambers, we can start to learn things about the risks that people actually face from air pollutants. So with those tools and environments, I expect students working with this EnvironMentors program to be able to formulate and then advance a project in one of these potential areas. Either comparing the performance of these commercial sensors with student-built sensors, evaluating the risks of specific environments or activities, and identifying what pollutant sources are responsible for those risks, and then testing the limits of the capabilities and the accuracy of commercial or student-built air quality sensors. And of course, there's possibility of combining one or more of these different initiatives into a single project. So these projects all present the opportunity to learn about data collection, air sampling, air monitoring, data analysis, statistics, and possibly computer coding as well, depending on the needs. So all that said, I'm very much looking forward to this year of EnvironMentors. Unfortunately, I was not able to participate during the last couple of years of COVID limitations, and I'm very eager to find out what we can learn together, especially after so much time that we've spent thinking or trying to avoid thinking about the risks associated with the things that we breathe in our day-to-day lives. So thanks for your attention, and I look forward to meeting you in person.